Welcome to Module 3, Lesson 1. So now we're going to be kind of taking a step back into some stuff that we've already talked about, especially in Module 1, and that is commutativity. Say it right this time. So I can study commutativity to find facts of 6, 7, 8, and 9. So we're going to kind of spend the next couple of lessons kind of rehashing this out, kind of reminding ourselves what does this mean, how does it work, before we jump deep into our next idea. I just want to make sure we have these ideas fresh in our head before moving on. So, long story short, we're just reminding ourselves that you can use one fact to find another. And this is a really, really nice tactic to know. If you have a big chart of all multiplication equations on it, if you don't need to memorize all of them. You actually only need to memorize like half of them. Let me show you what I mean by that. As a reminder, if we know that 2 times 4 equals 8, two groups of 4, so this, one group, two group, with 1, 2, 3, 4 in each group, is the same thing as 4 times 2, four groups of 2, which is 1, 2, 3, 4, with 2 in each. So 1, 2, 3, 4 with 2 in each group. They both give the same answer. That's commutativity. Remember that. Now, that is kind of what we're getting out with this. And the reason why we're specifying 6, 7, 8, and 9 is because 6, 7, 8, and 9, sometimes those are, at least for me, 8 is the big one for me on this one. But doing my skip counting, these are the ones that we usually slow down with a little bit, because skip counting by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not too crazy. 2's 2, 4, 6, 8, 10. Once again, not too crazy. 3's 3, 6, 9, 12, 15, 18, 21, 24. Not too bad again. 4's 4, 8, 12, 16, 20. 5's 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, so on and so forth. But once you get to 6, sometimes it can get a little trickier. And so if I had to do a math problem that required me to skip count by 6, let's say we did 2 times 6, I have two groups of 6, so I go 2, 6. But what if it was bigger? What if we had, let's say, 5 groups here? So now I'd skip count by 6 5 times. We're going 6, 12, 18, 24, 30. But let's say maybe you're not super good with your math facts, especially with 6. Maybe 6 are the ones you struggle with. And that's totally fine. Instead of going 6, 12, what comes after that? 18, maybe make a mistake in the next one you say 25, which will throw everything else after that off. Instead of skip counting by 6 5 times, use the commutative property. We know that 5 times 6 is the same thing as 6 times 5. Now we can skip count by 5 6 times, which, again, I'm not a fan of the word easier, but you're less likely to make a mistake counting by 5s than by 6s. By going 5, 10, 15, 20, 25, 30. So 6 times 5 is 30. So if I know that this right here equals 30, that means I also know that 5 times 6 is also 30. So this is, once again, is a very, very, very helpful strategy here. I use this one for 8s all the time because I honestly don't know why, but 8s are usually the ones that whenever I'm doing multiplication with, I always have to pause and say, okay, wait, am I doing this right? I think this is it. They're the ones I struggle with the most. 7s, I got the 7s down pretty good. 9s, I have 9s down pretty good. But 8s are the ones I struggle with a lot. So, to give an example of this, let's say if I had, let's say 4 groups of 8. And once again, you might be able to look at this and be like, oh, I can skip count by 8 4 times. I'm good in that. But to see, you might have a struggle with that. Maybe you're like, I don't know my 8s too well. I make mistakes really early with that. Well, that's okay. Remember, you can do 8 times 4, and it'll give you the same answer. Skip count by 4 8 times. 4, 8, 12, 16, 20, 24, 28, 32. Which means, you know, if 8 times 4 is 32, that means you also know that 4 times 8 is 32. So, once again, just giving a visual reminder on how this works. You will have questions like this in your homework and your problem set saying, hey, what is the commutativity of this? For this image, show me two multiplication sentences you can use, so on and so forth. And I also want to give you guys a reminder, because this is something that you need to know. I want to make sure we understand how to read this statement right here. 4 sixes. I want to make sure we know this, because this is going to be coming up a lot in this chapter, at least for the first half. So, 4 sixes. This is saying, how many sixes do I have? 4. I have 4 sixes. So I can alter this and transfer this into a multiplication sentence. I can say 4 is our groups. So I have 4 groups of 6. So 4 times 6. So 4 sixes is the exact same thing as 4 times 6. These are saying the same thing. Which means, if I know that 4 times 6 is, you can do that real quick, find out it is 24. I know that 6 times 4 is 24 by going 6, 12, 18, 24, or by 4s gets commutative property, 4, 8, 12, 16, 20, 24. That means you also know that 4 sixes is equal to 24. So get that down in your head, remind that. So just as another example, give you a couple more of those just as a reminder. If I have something that, just do something really big that we don't need to necessarily solve, but we understand what it means and what it's asking. 7 eighths. 7 eighths means how many groups do I have? I have 7. How many? 7 of what? I have 7 eighths. So 7 eighths means 7 times 8. So keep that in mind as we move forward with this next thing. Because I can change this problem to say something else now. I can break it up. Remember, like when we had a tape diagram or an array, we would cut it in half, solve them separately, and then glue them back together. So just a quick, small, simple example here. I have a 3 by 3 here. I could cut right there, say that this is how many groups? 1, 2. How many in each? 1, 2, 3. 2 times 3. This one down here is one group of 3. That is 6. This is 3. Together they are 9. So the entire thing is 9. Kind of a sloppy 9, so close it up there. So just get a reminder, keep that in mind as we move into this next step. So what you can do is that you can use this unit form to solve very similar problems. Let's say I have 2 4s right here, 2 4s, and I say plus 3 4s. Now, once again, if you look at this, you might be like, what? I don't know what this means. But think back to how we just kind of talked about that array. You take an array, you split it into 2 smaller pieces, solve them separately, and then you stick them back together. Remember that. Instead of looking at this problem as a whole, let's look at the smaller sections and see what we can do with them separately. So right now, let's ignore 3 4s, and let's just look at 2 4s. So 2 4s, the 2 stands for how many groups we have. So we have 2 groups of 4. So 2 times 4. I'm going to put those in parentheses right now, saying they're together, they're doing their thing together. I'm going to drop down that plus sign. The 3 is how many? How many groups? 3. How many groups do I have? Oh, I have 3 groups. How many are in each group? 4. So now I have 2 4s plus 3 4s is the same thing as 2 times 4 plus 3 times 4. Once again, these are saying the same thing. They look a little bit differently visually, but they're saying the same thing. Remember that. And I can go ahead and solve this. 2 times 4 is 8, plus 3 times 4 is 12. Add that up together, you get 20. Which means I know that 2 4s plus 3 4s is equal to 20. But let's hold off just a second there. This is true, but before we get to that step, we can do something else. Right now, I've solved these separately, and then I've glued them back together. I did that evidently here. Solve this separately, put them together to get 20. Now there is one other thing that you can do here. Remember how I said that in your picture, I'll even draw this out. So 2 4s, 2 groups with 4 in it. And the bottom one is 3 groups of 4. And they're cut right there. Here's 2 4s, here's 3 4s. Now, on the other problem we just talked about, we could technically just straight up solve it all together, right? And the only reason why we can do that is because they have the same amount in each group. Every single one of these have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. They all have 4, which means you're allowed to just do it all together. So let's count up how many groups of 4 we have in total together. Ready? 1, 2, 3, 4, 5. So how many 4s do I have in total? 5 4s. So I took the 2 and the 3, added them together. So if I have 2 4s plus 3 4s, that means I have a total of 5 4s. Hopefully that makes sense. Because I know sometimes during this part we're like, not sure what's going on. Basically what I'm saying, I could say this instead. I have 2 Skittles plus 3 Skittles means I have 5 Skittles. I have 2 groups of 4 and 3 groups of 4, which means in total I have 5 groups of 4. So same idea. And I can transfer this into a multiplication sentence too. How many groups do I have? 5. How many are in each group? 4. 5 times 4. And you can skip count by 4 5 times to see if it does equal 20. If it does, we've done this right. 4, 8, 12, 16, 20. Look at that, we're at 5 and we hit 20. So this also works. This is a method that is very, very handy and you are going to need it in order to do some of these problems. Which means, I'm going to go ahead and erase this bottom part right here. I can do something uniquely with these as well. If I can combine 2 4s plus 3 4s to equal 5 4s, without solving these, I can connect these two as well. And we already know what they connect to become. I'm going to erase this real quick, because we already wrote it down right there. I can also say that 2 times 4 plus 3 times 4 is the same thing as 5 times 4. Now this might be a question of, wait, Mr. Luthi, but you're supposed to do multiplication first. And you're absolutely correct. In the process, you do parentheses first and you do multiplication first. And then at the end, that's when you do addition and subtraction. You're absolutely right on that. But there's this really fancy, cool thing with math. Let's redefine what each one of these things means. The 4 for both of these represent how many are in each group. When we've talked about breaking apart things, we've talked how you cannot change how many are in each group, period. If you want to have things be multiplied together, they must have the same in each group. They have to. Now this top word for each one of these represents how many groups there are. Now this is the one that's a little bit more flexible, because if I have 2 groups of 4 and 3 groups of 4, well, I can just say I have 5 groups of 4, like up here, and just say they all have the same amount, so I'll just do them all at the same time. So you can do that. You can just say, well, this is groups. Groups and groups can be added together. In each group and in each group will stay the same, because has that number changed? When I have this picture, 5, with 4 in each one of them, when I draw a line right there to represent 2 groups of 4 and 3 groups of 4, when I erase that line, did I change any numbers? Did I change anything? Well, there's still 2 up here and 3 down there, but now there's, if I added them all together, there's 5. Did the amount in each row change? No, it's still 4, which is why the 4 stays the same here. You don't change that. Now, just kind of an extension, this is kind of as far as you need to take it, but let me give you a hypothetical problem. What if I gave you, I'll stick with the 2 times 3 right here, plus 3 times, I'll use a different number just to make sure we're not getting confused with here, 1 times 4. Can I combine these ones? And before you kind of think of an answer in that, think about this. What was the number 1 rule about gluing 2 arrays together? What was the number 1 rule in that? The number 1 rule was that they had to have the same amount in each group. The group amounts didn't matter. It didn't matter if there's 5 groups over here and 4 groups over there. It only mattered if they had the same amount in each group. So when I look at this 2 and 1, do those matter? Do those matter in determining if we can put these together or not? The answer to that is no. Not. And I could draw this out. So I have 2 groups with 3 in each group. Now over here, how many are in this group? First off, there's only 1 group. I'm going to mark these ones with X's so you can visually see the difference here. And there's 4 in each group. Now, can I put these together to create one math problem? No, we can't. Because if I say I have 3 groups, I would say 3 times, well, how many are in each group? Well, up here is 3, but down here is 4. Are they the same? Are they all the exact same? Oh, no, so we can't connect these ones. These ones must stay separated. For this, you have to solve this separately, solve that separately, and then you add them together. So just kind of keep that in mind. You shouldn't have to worry about that too much yet, but just keep in mind as well, 2/3 could be represented as, actually, I'll just go ahead and just do another quick one for you to give you a visual. I could say, I'll just do one that it doesn't really matter if we solve it or not. If you want to solve it, you're more than welcome to afterwards. But it's 5 4s plus 4 4s. You could rewrite this in 2 different ways. One, I want you to do both. 5 4s plus 4 4s would equal 9 4s, because I have 5 groups of 4 plus 4 groups of 4, which means I have 9 groups of 4. Or I can translate this into 5 times 4 plus 4 times 4 equals 9 times 4. If you want to solve 9 times 4, that's fine. You're more than welcome to do that. But I just kind of want to know this is the strategy and what we're going into in the next couple of days. So hopefully this was helpful. Hopefully you got something from this, and I hope you guys have a great day.